Hello, welcome to another session of Digital Forensics and Investigation. In this session, we will be discussing SD card and feature phones. So we will see what is SD card, types of SD card, and different type of securities available in the SD cards. Then how we can extract data from the SD card. And then we will see what is feature phone, the characteristics of those feature phone, and forensics tools that we can use to extract data from feature phones. So SD card, also known as Secure Digital Card, is a non-volatile memory card developed by the Secure Digital Association (SDA) for the use in portable devices. So it stores additional amount of information for you in any electronic device which can support those SD cards. So it is used for the mobile devices such as cameras and smartphones, for example. SD cards are also available in various sizes. The three form factors are original size, the mini size, and the micro size. So electrically passive adapters allow a smaller card to fit and functions in a device that is built for a larger cards. So SD card small size is an ideal storage medium for smaller, thinner, and more portable electronic devices. The second generation SD card, also known as Secure Data Card or SDSC card, was developed to improve the multimedia card standards, which continue to evolve but in different directions. So Secure Digital or SD card changed the multimedia card design in several ways. So the asymmetrical shape of the side of the SD cards prevent inserting it upside down. Most SD cards are thicker than the multimedia cards. The card electrical contacts are located beneath the surface of the card, protecting them from contact with the user's finger. The SD card capacity and the transfer rate are more than the multimedia cards, and both of these functionalities have grown over time. The multimedia card uses single pin for data transfer, while SD card added 4-wire bus mode for higher data rate. So full-size SD card do not actually fit into a slimmer multimedia card slots. We have another and advanced version of the SD card which is known as the Secure Digital High Capacity Card. So this card format supports cards with a capacity up to 32 GB gigabytes. So SDHC cards are physically and electrically identical to the standard capacity SD card, and the major compatibility issues between SDHC and SD cards are the redefinitions of the card specification data register and the fact that uh, SDHC cards are shipped pre-formatted with the FAT32 file system. So SDHC host devices are required to accept older SD card. However, older SD or older host devices do not recognize SDHC cards or SDXC cards, but sometimes it works with the firmware upgrades. Then we have another advanced version of the SD card which is known as SDXC or Secure Digital Extended Capacity format. It supports cards up to 2 terabyte, and SDXC adopts Microsoft Extended FAT file system as a mandatory feature. Then we have another version, latest version of the SD card, which is known as SDUC card, which stands for the Secure Digital Ultra Capacity. So this format of the card supports memory up to 128 terabyte and offers speed up to 985 megabytes per second. So regardless of the form factor, either micro or the full size, the speed is about 985 megabytes. SDXC and SDUC cards are normally formatted using the extended FAT file system. Okay, so SD cards can protect their content from modifications and from deletions and can also prevent access by the non-authorized users. The host device can command the SD card to become a read-only memory. So we have a write protect notch on the SD cards. So most full-size SD cards have a mechanical write protected switch, allowing the user to advise the host computer that user wants the device to be treated as read-only device or read-only memory. So this does not protect the data on the card if the host is also compromised. So the switch is a sliding tab that covers a notch in the card. So the mini SD card and micro SD card format do not actually directly support a write protect notch, but they can be inserted into the full size adapter, which can do this for the mini and the micro size SD cards. So when looking at the SD card from the top, the right side must be notched, and on the left side there must be a write protect notch. And if the notch is omitted, the card can be read and write. If the card is notched, it is read only. Okay, so if the card has a notch and sliding tab which covers the notch, the users can slide the tab upward in the upward direction to declare the card as read and write card, or in the downward direction to declare it as only read only card. We can also protect the card using passwords. So a host device can lock an SD card using a password of up to 16 bytes in length. So typically supplied by the user. So the user enter that 16 byte password. A locked card interacts normally with the host devices except that it rejects commands to read and write data. So it interacts, but it doesn't allow the user to read and write data. So a locked card can be unlocked only by providing the same password, of course. So the host device can, after providing that password, specify a new password or disable locking mechanism. So without the password, the host device can command the card to erase all the data on the card for future reuse, but there is no way to gain access to the existing data. Okay, so the digital acquisition from the electronic device is usually split into two categories, like data acquisition from the internal storage and data acquisitions from the external storage. So most of the Android and feature phones support SD card to extend the storage capacity. And people store their valuable information in those extended memories. For example, documents, pictures, videos, contacts, etc. So during the forensic investigation, it is important to extract data from those extended memory, which are actually these SD cards, secure data cards. So there are various methods of data extraction from those SD cards. For example, using FTK imager and write blocker. So in this case, SD card is connected to the write blocker first, and then that write blocker is connected to the forensic workstation where FTK imager is running. So then FTK imager takes an image and extract data from the SD card using the write blocker. Mobile forensic equipments can also be used to do the SD card data extraction. For example, Celebrite provides memory card reader for the SD card data extraction. So in this case, an SD card is inserted into the memory card reader, and then it is connected with the forensic workstation to extract data using Celebrite UFED for PC software tool. A feature phone can be described as a wireless mobile device that has more features than the standard cell phone, but limited capabilities when you compare it with the smartphone. So feature phones typically provide a calling feature, messaging functionality, and multimedia message service like MMS support. They also offer the basic multimedia and the browsing internet capabilities, as well as other services offered by the selected service provider. So feature phone and the basic mobile phones tend to use exclusive software that is custom designed for the specific user interface, while smartphones often use a specifically designed mobile operating system that shares common characteristics across various devices. So technologies and the hardware seem to be obsolete when considering the feature phone. But for the forensic examiner, digital evidence lays the foundation for any investigation. Hence, the forensic examiner has to be fully equipped with the tools and techniques which supports the latest as well as the obsolete technologies. So at some point, a forensic examiner may have to face feature phone forensic investigation, especially when people related to terrorism, hacking, or secret agents, etc. Those type of people are involved. So then the investigator may face the feature phone for the forensic investigation. So one can extract data like SMS, contacts information, installed application, GPS data, emails, and even the deleted files. But there are a lot of dependencies and challenges when performing forensic data extraction from feature phone. The characteristics of the feature phone can be described by comparing its hardware and software configuration with a smartphone. So this will help us to understand and give us more complete understanding of the feature phone. So along with these hardware differences, as you can see, the display, memory, camera, processors, text input methodology, card slots, positioning, batteries, display, and cell interface. So the smartphone's display is usually very large, while the feature phone display is small. Same if we compare the capacity. So capacity of the smartphone is very large, while the feature phone capacity is very limited. Same for the camera. Camera is very high definition and very sophisticated in the smartphones, but feature phone camera is okay, may not be very high profile camera or with a high resolution. Same for the processor. So smartphones processing speed is very high. Processor is very high end processor they use, while the feature phone processor speed is limited. So along with these hardware differences, many things on the software side serve to be differentiate between the two. So a few basic features such as the voice calling, text messaging, and few personal information management applications like the phone book and the calendars are similar to the smartphone, but the smartphone employ a lot of like PC-like activities. For example, high resolution display, computing capacity, and a wide variety of applications available on the smartphones. But we can't do these things on the feature phone. So the operating system in the feature phone is completely closed. No documentation exists for the same from the manufacturers. But on the other side, smartphones runs a multitasking operating system, which is either proprietary or open source in nature. So as the feature phone has a closed source operating system, the development cost for such operating systems are paid by the company itself, who hires the developer and guides the project. So as I said, smartphones operating system is open or might be a proprietary, but the people can develop applications for them, and that can be adopted and will be working on the smartphones. But in the case of the feature phone, the operating system is closed. No one knows how the operating system was developed for that. Only the manufacturer knows, and they hire the people and uh, they develop applications for the feature phone. Now, mobile device memories can be categorized into two sections like volatile memories and non-volatile memories. So volatile memory includes RAM, random access memory of the device, which is accessible to all the applications without user's permission. And it is lost, or the content of the RAM will be lost when the device loses its power or when the device will be switched off. The non-volatile memory is the persistent memory which is not affected due to the overwriting or power loss. So this is a memory type which stores all of the data on that memory device or on that mobile device. The non-volatile memory is further classified into NOR flash and NAND flash. Among these two different type of flash memories, NOR flash memory is faster to access and is very much secure, while NAND provides a higher storage capacity and sequential access. So NAND is a slower memory but provides a very high capacity. But NOR is a high faster memory, but uh, the capacity is less as compared to the NAND memory, but NOR is more secure than NAND memory. So under the GSM framework, mobile device is referred to as the mobile station or the mobile equipment, and it is partitioned into two distinct components like Universal Integrated Circuit Card like UICC and the mobile equipment ME. So a UICC, which is Universal Integrated Circuit Card, commonly referred to as the Identity Module or Subscriber Identity Module, SIM, sometimes USIM, or sometimes a CDMA SIM, which is known as CSIM. It is a removable component that contains very important information about the subscriber. The mobile equipment and the radio handset portions cannot fully function without a SIM card. And the SIM's main purpose is authenticating users of the mobile device to the network, the service provider, which is providing services to the to the subscriber. The SIM also offers storage for the personal information such as phone book entries, text messages, last dial number, and service-related information. So, feature phone operating systems are typically closed, and closed operating systems make interpreting their associated file system and structure very difficult. So many mobile devices with the same operating system may also vary widely in their implementation, which results in many different type of file system and structure permutations. And these permutations create significant challenges for the mobile forensics tool manufacturer and also for the forensic examiners. So the type of software available for the mobile device examinations include commercial and also open source forensics tools, as well as non-forensics tools, which are intended for the device management, testing, and diagnostic. So forensics tools are typically designed to acquire data from the internal memory of the mobile device and also from the SIM cards without altering their content, and also calculate hash values to preserve the integrity or to check the integrity of the data. So both forensic and non-forensic software tools often use the same protocols and techniques to communicate with the device. However, the non-forensics tools may allow unrestricted two-way flow of information and omit data integrity hash functions calculations. So mobile device examiner typically assemble a collection of both forensics and non-forensics tools for their toolkit. So the range of the devices over which they operate is typically narrowed to specific platform or a specific operating system family or even a single type of hardware architecture. So due to a short product release cycle, the tool manufacturer continuously update their tools, providing forensic examiner with a forensic solution. But the task is very challenging, and tools for the newer model may lag significantly behind the introduction of a device into the marketplace. So models of older functioning mobile devices can remain in use for several years after their initial release. So the tools for that older version might work for the new version of the same model. So we have different forensics tools that can be used to extract data. For example, Tulip 2 is a freeware tool developed in the Netherlands. So the user interface is not that attractive, but it is relatively simple and easy to use to extract data from the feature mobile phones. We also have Mobile Edit Forensic that was developed from the Mobile Phone Manager program, and its report is MD5 hashed value, and so no tampering is possible uh, because of those hashed values. Oxygen Phone Manager initially was an agent that was used for editing information present on the mobile device using a computer. We also have P2K Commander. So the P2K Commander can browse ABC and other folders using the data or fax connection modes. It supports a change of file attributes and all operations. It also accesses photos, MP3 files, packet logging, and work with other P2K phones over the USB LAN. We also have NSS Pro, which is actually a Nokia Service Software Pro, and it is a tool for the Windows that can perform various functions related to the Nokia using the workstation or the forensic workstation. It provides detailed phone information, factory reset option, flash and software updates, etc. It can read and reset security codes of the phone that are supported if it supports that uh, mobile phone. It helps to unlock SIM card, test the phone's feature, and perform various other tasks. So we also have like a flash and backup tool, which is basically used to upgrade the Motorola firmware and restore the original configurations. So it enables the examiner to recover all the data and content from the phone memory. So this tool is considered to be efficient to create a backup and recover data from the Motorola mobile phones. Last but not least, we have the Celebrite UFAT4 PC, which can be used to extract data from different type of iOS and Android mobile phones. So this brings us to the end of this very brief and short session about the SD cards and feature phone. Thank you very much.